Hi friends, uh, welcome back. Yesterday we last session we had discussed on the process mapping, and after that today we are going to discuss a little bit on the data analysis part. This is the fundamentals, and if you already have gone through few of the broad histogram and all those which we discussed in the define phase, this would be easier for you. Now before in this session, I'm going to share only about the normal distribution. What is normal distribution? But before that, let me give you a broad example of what exactly is a distribution, right? So let's take an example where you have some delivery services. You have any online delivery services, and for each and every order there is a time, right? So this is 51 minutes, 132 minutes, 90 minutes. You have all these numbers as delivery times, right? Now once we have this data, what do we do this with this, right? So if we don't use it as statistically, even if we don't use it as statistically, and let's try to create a histogram, right? So in Excel the easiest thing to do is create a pivot, insert, create a pivot table and new worksheet, right? I'm taking the delivery times here and taking the counts here, right? Let me sort this, yeah, and here, right? So now so these are the time 1 2 3 4, these are the minutes, right? And we can see this goes up to 500, yeah. So this is about 588, right? That's the highest. Now what do we understand in terms of data? So if we group this is how you can do it. Let's group it with maybe 50, right? So now this will show us a data of grouping. Just a minute. Okay, let me take this data again, which I already sorted in a different sheet, removing the decimals. This would be easy for us to understand, right? So what I'll do is I'll just put counts here, right? Summarize value, show value by count, and then I'll group this with 50. Right? So now if you see, what does this mean is we have 42, between 42 to 91 we have two values, then 92 to 141 we have one value, right? Similarly we have 192 to 241, 15 values, right? Like this we have some values here, and to understand it, let me go to here, and this is the normal distribution. This is, I'm not taking any statistical measures here. This is only a simple normal distribution, right? I have taken a histogram here. Now if you see this, you can understand the delivery time. The organization needs about 342, this one, and 392 to 441. So maximum duration of time is covered within 342 minutes and 441 minutes, right? So anyone seeing this data, they can understand that, okay, the average is, the mean is, without calculating anything, the mean is about 342, 391, right? Now how does this change when when we convert this to a normal distribution, right? So this is a histogram only. Now we will go to the statistical distribution, right? Uh, so to I have some other videos also earlier where I had shared with you all how to construct a distribution, statistical distribution. Let me do it again for you here, right? Though I have done it here, let me do it again. The first thing you have to do to construct a probability distribution is find out the mean, right? This equal to mean. I need mean of this entire data set, right? Right. So the mean is 409. This is I calculated earlier, and same way you can calculate the standard deviation, which is 96. So let me show you how to do it. So this is standard deviation of population I am taking here. Won't make a huge difference even if you take anything else, right? Okay, so this is our mean and this is our standard deviation. We have the mean and standard deviation. In Excel, you can easily construct a standard normal distribution. For that, what you have to do, you have to find out normal value, the normal probability value of 42. So for it, delivery time of 42 with mean 409 and standard deviation 96, we have to find the probability of 42 occurring. What is the percentage of time 42 will occur in case it's a standard normal distribution. So to do this, normal distribution, see here you will get normal distribution. X is the value for which you are using this, comma, the mean is 409 and standard deviation is 96. Now we don't need the cumulative distribution function here, we need the probability mass function, right? Now let me change this to number, right? So this is the number and we can change this to percentage. Now it is showing 0 because this must be, yeah, so this is about 0.000. After that we have the numbers here, so that's why we are getting it. In case you have any doubts, anything, you can share in the chat box and I can revert to it. That's why I started live sessions. People requested in mails. Now let's freeze all these three, right? C2 we don't need to freeze. M2 and M3 we have to freeze. Let me freeze this. M2, yeah. So now we can just, so let's say column number O, and we have to go up to the last, so column number O, right, and paste. Now all this numbers represents the probability of this delivery time. What it means is, if we have a delivery time of 112, or in other, what is the probability of 112 occurring in this business, in this process, right? So currently we are saying it is about 0.01% something, right, for 112. Now if you group this the way we grouped it earlier, you will get the percentages here, right? You will get the percentage of time this value can occur, right? So let's replace this with the percentage and then we'll see what value we are getting there. Copy. Okay, let me do it here only. It's better to do it here. This may not take the values. Probability. I have to bring it here for easier. And now I can do it easily. Right, so now we'll take delivery time in rows, normal distribution here. This we will take as sum. There's no calculation we need, and we might have to change this to general to number, right? And then we'll change it to percentage. Yeah. We have some duplicates value here, otherwise this should be 1, the probability should always be 1, right? So in case we'll go back to our data. And let's put this one only as a histogram. Right, so now we are seeing the probability plot. See, here you can see the plot looking mostly like a normal probability plot, right? Now the same thing, same delivery time, if we take in Minitab, and let me show you in Minitab how it should work. So delivery time, I already have it here. To create a, you can just go to the basic statistics and graphical summary in Minitab, right? Delivery time, and okay, so now you can see here the normality, the normal curve, right? Here we have a mean of 408. There will be some error between Excel and Minitab, the way they calculate, and specifically when I copy paste the data here in Minitab, it doesn't take the decimal values and all those details. That's why you might see some differences here, right? Now if we go back to here, so what is normal distribution? Now normal distribution occurs in many natural phenomena, what I showed you earlier just as an example. So first the distribution, then you convert it to a normal distribution, such as height, blood pressure, length of object. So if you take the distribution of all this, that would tell you what distribution it follows, right? How you can use it, we will check in the next slide. What does it mean, right? Now certain data when graphed as a histogram creates a bell-shaped curve known as normal curve. That's why it is called a normal distribution, right? Symmetrical with a single central peak at the mean average of the data. The way we saw, so you will have a central peak here in the mean, and then you can have the standard deviation, which are, these are the standard deviation, right? 50% of the distribution lies to the left of the mean and 50% lies to the right of the mean. So if I show you like this, 50%, this is this data, so this distribution has this part 50% and this part 50%, right? The middle part constitutes about 34 plus 34%, which is about 68.2% of data, right? Now you can understand why we call it as a 6 sigma, because here for a normal distribution, this side you have 3 deviation or 3 sigma, this side we have again 3 deviation or 3 sigma, right? So that's why we call this as 6 sigma, right? Anything within this, any data point should fall within this. So if you go back to our data, the this data, right? So any point lying outside this 3 deviation, right? 3 sigma, which is 3 into standard deviation, which is 3 into 96, right? That is the anything after this is considered as outlier. So in your process to be 6 sigma, you have to ensure that all those data point lies within this, right? It should not go out of this 3 sigma. Then it's an outlier and your process is not performing, right? Now how do we use it in a practical environment? Suppose a class has 2000 students and the average marks for candidates follows a normal distribution with a mean of 65 with a standard deviation of 100. What is the percentage of candidate having marks? This is the problem we are solving. Now let me take, this is easy to do in Minitab, so let's do it in Minitab. I'll go to stat, I'll go to graph, probability distribution plot, right? Now check here, what we are trying to identify here. We are trying to find out, we are saying the mean is 65, right? That means this is 65, this mean, this 0 in our problem, this 0 is 65, right? With a standard deviation 10. What is the candidate percentage? What is the percentage of candidates who are having marks 80 or less than 80, right? So in this graph, if 0 is 65, where would 80 lie? That first you have to check, right? So 80 will be here somewhere, right? It is greater than, so this side would be plus standard deviation, right? 65 plus 1, 2, 3 standard deviation. So this is 65 plus, so 80 will lie somewhere here, right? Now go back to our Minitab. What we are trying to calculate? We are trying to calculate x. So we'll see the probabilities, right? Okay. Now it is a normal distribution. The mean is 65 and standard deviation is 10. Then shaded area. What we are trying to identify? We are trying to identify what is the percentage of candidates having marks less than 80. Right? So what we are trying to do, we are trying to find out people who are in this shaded area, right? In this non-shaded area, right? So x value is, let's take 80. Okay. So now if you see, 80 lies somewhere here, and after 80 there is only 0.066 81 decimal. So if we convert this into percentage, this would be 6.68%, right? So 6.68% candidates are 6.68% candidates are outside 80. So if we have to get how many candidates are within 80, we have to subtract this from 100. So this equal to 100 minus 6.6. So I think I'm getting some error here, but broadly it should be about 94 or some percentage, right? Now to the second part of this problem, how many people are greater than 90, right? Greater than 90 means what we have to do? We'll go here again, shaded area 90. How many people are greater than 90? Okay, so you can see here only 0.6%, right? This 006 means 0.6% of candidates are outside 90 marks, right? Then we have to check how many people are between 70 and 90. So here, shaded area. So we are trying to check two numbers. First value is 70, second value is 90, right? So within 70 and 90, 30% of people are there. right, or students are there. So that's how you use normal distributions. In case you have any doubts, anything, share in the comment section or mail us. We will revert to you in the next session, right? Also, what you can do is, this is a plot a rough sketch to calculate the Z score, right? So we will see what is the Z score and all those. We already have learned it earlier, but try to do this, and again in the next class we will redo all these things including the Z scores, and then we will match it with our Minitab data, what it is showing, right? And also we will complete the binomial distribution. Thanks for watching. Share your views and feedbacks, would be helpful. Thanks a lot.